Salutations, it is I, Monaco, with our third homework lecture on the history and periodic law. So we're going to do a little history lesson on where the periodic table came from and see where we're going to take it. So how did the periodic become such an iconic image? Let's give it a shot. First thing you got to know is that Dmitri Mendeleev was the guy who came up with the first periodic table. And he was a Russian chemist in the late 1800s. A lot of good things have come out of Russia for chemistry, specifically the periodic table and distillation of liquids. He was a lecturer at the University of St. Petersburg, so he was a professor and he gave lecture. Rumor has it that he was late for a lecture and he took out a stack of cards of the elements with their atomic weights on them and arranged them and realized that there was a pattern going on here, and he decided to run with that and do a lecture on that, and eventually it became a cultural thing for us chemists. We had a periodic table, ba-boom, some guy just put the elements in order. And now that might seem really simple to you and I, but back in the 1800s it was kind of a big deal. And what was even a bigger deal was that he grouped the elements vertically as well. So it's not like he just put them in order from like A to Z in a line. He also stacked them too. So he realized when to start a new stack was when the properties of the elements started to be similar and the reactivity started being similar. So hydrogen, lithium, sodium, all those things were put in the same column over there on the left here because they had similar reactivities. Okay, and he realized that there must be something to that. But even more so important, he saw big gaps in masses and the properties, and so he left spaces for undiscovered elements. We chemists often think that we already know everything and all, but as a matter of fact, we scientists should know that we don't know everything. And he left blank spots in his periodic table, like these, to say, listen, man, something might go there. We haven't figured out what it is, but if something does belong in that spot, it's going to be a lot like aluminum or anybody else in its group, and it's going to have a mass between 40.1 or 47. So he made some pretty accurate predictions by leaving gaps in his periodic table. Well, a few years later, in the 1900s, early 1900s, this guy named Henry Mosley picked up the ball that Mendeleev started rolling and said, I'm going to take this to the next level. And he was a British chemist, and he took Mendeleev's periodic table and said, there's some great ideas here. I like how we've filled out some of the gaps since last periodic table, but I'm going to make it a little bit better. I'm going to rearrange it. And so what he did is he used the protons and subatomic particles that had been discovered since Mendeleev's table to serve as the backbone for his new arrangement. And so instead of ordering by the atomic weight, which was a relative thing that Mendeleev used, he ordered the elements by increasing atomic number, or the number of protons. Since Mendeleev's time, they had figured out the number of protons for all these elements that were already well known. And he said, listen, I'm going to just go by 1, 2, 3, 4, 5, 6, 7, all the way up. Okay? Instead of atomic weight, I'm going atomic number. I'm putting them all the way up. And then he also kept them in the vertical group. So there was only a few slight rearrangements that Mosley proposed to Mendeleev's table. And lo and behold, we have the new periodic table, which started to elucidate and formalize the periodic law, which is the chemical properties of elements are a function of their number of protons and repeat at regular intervals, creating the groups of the elements. So that's why to a chemist, the periodic table is so amazing. It's not because it's just a chart of all the elements, but because this chart of all the elements shows in multiple dimensions the properties of the elements. And you can look at a periodic table and decide where physically, top left, bottom right, an element is. And a chemist, and you, after you're done with using it, can say, I can tell you what some of the properties of that element probably are. Even though I don't have a chunk of it in my hand, I know that that element belongs in this particular area of the periodic table, which means that it has the following properties. And so that was a big deal. It might not seem like it to you, but it was a huge deal at the time because it formalized the elements that were known and arrange them in a very, very useful manner. So, for your Google Classroom assignment, I want you to complete all these written notes, and then I want you to complete the online portion of this homework. And I want you to come to class to be ready to go over page 6 on the periodic table packet. But most importantly, see if you can do it first. Okay? See if you can do page 6 without coming to class, based upon these notes only. So thanks for watching. Next video is groups and periods. So we'll see that soon. Adios.